Hello everyone around the world. So today we have a job. This job, that's the job. If you if you check close to our sticker here, the job is coming from the local capital city of Zimbabwe. That is Harare. The guy phoned me. He explained everything about the motherboard. They are also doing electronic sales and repairs in the capital city, and it's a very prominent, well-known company. He said, no, if you can try to fix it, because we've been watching your videos on YouTube, and we are 100% sure you can be in a position of doing something. You know, when someone is giving emphasis and someone is 100% confidence that you can do it, at the end you fail. Yeah, you know the feeling. So this is a case. Which is quite tricky, because already the guy has 100%, more than 100% confidence that we can do it. Of course, behind the scenes, we are not fixing everything. So the issue about this motherboard, he phoned me. He said we are a big company. As we are a big company, if you can do a video, please don't mention our details, because maybe we have some customers who might pass through your channel and they will lose trust from us. So I have to listen to the customer. These are very important, crucial words. So that's the motherboard. Yeah, from Harare. The motherboard, they said it's not turning on. So we have to see what is here. What is coming from the capital city of Zimbabwe. Yeah, we received this package like a few days ago, but I was kind of busy. I explained, just to give me some time, I'll do the job for you. If I can, I'll do the job for you. If I can't, yeah, I will tell you this is beyond our capacity. So we have the motherboard, and for sure, I never deal with such kind of motherboard. That's the motherboard. I'm not sure what model of this motherboard, but looks like an Acer, or under the category of between Acer and Acers, yeah, so to say. Between Acer and Acers, but we'll see about this. That's the motherboard. Very nice motherboard. And we have the charging port. Based on the charging port, this must be an Acer, right? Fine. What is here? BST what? Huh? Do you have a letter? Do you believe someone write a letter? Huh? These are professional guys from the town. And don't get me wrong. Being professional, it doesn't mean that if you are professional, you are now in a position of fixing everything. Let's open up the letter. Let's open up the letter. I'm curious to see what did they say about this motherboard. Maybe you can have a starting point. Okay. To BST African Electronics Surgery, Rwanda, Zimbabwe, till number sale. Ref Acer motherboard not powering on. I'm a technician based in Harare, capital city of Zimbabwe. I've sent an Acer laptop motherboard for diagnosis and to be repaired at your workshop. I was inspired by YouTube channel. I believe I've sent to the right workshop for a proper repair. I tried to help my customer who really wants the laptop alive, but unfortunately I failed. Kindly take a look and help. If you can, do a video If you don't mind, that might help. Okay. That's the letter. That's the letter we received. So, you know, when someone give you emphasis, give you the trust, give you everything, make you the last hope. Huh? You know that kind of job. And at the end, you can't fix. At the end, the CPU is faulty. Huh? You know that feeling. You feel like you did not do the job the proper way. You feel like uh, you are not a professional like the way how the customer was seeing you. So let's try to help this technician. This is a motherboard. And what we know is it is an Acer motherboard, but he did not mention about the model of this Acer. So what I can do, what I can try to do, I can try to write the board number. It's C5. Because I want to know this motherboard is for what laptop. PREF 1A laptop model. Acer Aspire A515-G51. Okay. That's for Acer A515-G51. So we know this is an Acer motherboard. So we have to see what the motherboard is doing. We have to see. With the help of the power supply, let's see what this motherboard is doing. But before we put this motherboard on power, what we can see on this motherboard? What we can see on this motherboard, because if we can't see anything, we are not going to help the customer. Here we have ENE. That is the microcontroller, the startup chip. Here we have some coils around the motherboard, which represent various kind of power supplies. Here we have the biggest chipset on this motherboard, which is the CPU, the processor. So this is the kind of motherboard with CPU and PCH in one chip. Maybe together with the Intel graphics. I don't know much about that because we don't have the schematics. But if I look here, we have a dedicated graphic chip. That dedicated graphics, because here I can see some memory chips, and we have some power supply here. So this power supply is most likely to be for the GPU, and this power supply for the processor, the vehicle. And we have this one next to the RAM, DDR4 RAM socket. This is most likely to be the RAM power supply. And here we might have 3.3 and 5 volts on this area. And what else? On the other side, we have few components, but we have those 4 memory chips, which represent that this memory has got an onboard RAM memory, right? This is onboard RAM memory, and we have another slot for the removable RAM DDR4. We have the charging port, MOSFETs, and the current sensor. We might have a look on the under microscope. Maybe we can spot something before we start the job. So here we have the E.N.E, that is startup chip here. You see this big chip? That's E.N.E KB9022Q. We have some power supplies all over. What we are looking for? We are looking for any missing components or any corroded chip or anything. The board looks okay from microscope point of view, but here looks like, if you check this coil, is slightly different from other coils. If you check here is brown, but here it is black. That's a sign that under this power supply, the coil suffers too much heat. This is a sign. This is a sign that something happened here. Why here is black, here on all other coils not black? Okay, let's leave it like that. Let's flip the motherboard on the other side. Okay, this is just a random check. We don't even know. Here looks like this pin, these 2 pins, they are corroded. We are just checking. So on the input section, we have those MOSFETs. So let's plug the power supply and play with plug in the power supply. It's taking 1 milliamp. I want to check the input voltage. Here we are not in a rush because the customer requested for a video, so we have to do it slow for him to understand what we are talking about. Here we have the plus wire which are coming maybe here, through this inductor. After the inductor, and then it's coming straight to this side, 4 pins together. That is, we do have 19 volts here, and on all the pins, because this is the drain of the MOSFET. This is the drain of the MOSFET. All pins we must have voltage, and on the output 3 pins, we have 19. On the gate we have 25 volts. So if we have 25 volts, this must be an N-channel MOSFET. Here we have 19. This is the second MOSFET. On the output of the second MOSFET is the drain. We do have 19. On the current sensor, this black resistor, We have 19. So the input section is working fine. Okay. What is the next step? The next step is to locate the BQ chip and see if the BQ chip is receiving the input voltage. Where is our BQ chip? Here we have BQ. We have BQ 735. On the BQ chip, I can see this big track. This must be the V in, where there's a capacitor, this one. And we do have 18.79 volts, which is coming from this resistor through this. Here we have 19. Here we have 19. So this must be a double diode. Yeah, this must be a double diode. So from the input of this double diode is going to the VCC, the 19 volts. So the BQ chip, we do have 19 volts, and pin number 1, 2, 3, 4, 5, 6, which is here. This is the AC detect pin. 0.6 volts must be above 0.6, 2.5 volts. Okay. And we have the 5, 6, 5, 10, 15, pin number 16 here. We must have 6 volts. This is the linear regulator output, 6 volts. So on the linear regulator output, we do have voltage. So we assume the BQ chip, everything is fine. The next step is to check voltage on the coils. We have to check voltage on the coil. On this coil, we have 3.3. On this coil, we have 5 volts. So the 5 volts and the 3.3 is okay. So which connector is going to the switch? That is the next step. Which connector is going to the switch? We do have 19 volts. We do have 3.3. We can check on a different power supply, even here, on this ceramic capacitor, to confirm the 19 volts. It's 19. You can see? Even here, we have 19. On another power supply, which is next to the RAM slot, we do have 19. So my question is, we have where the connector is supposed to be. We don't know, because I never fixed this motherboard. I can't see. What about here? Okay. So what anomaly did we notice so far? I noticed 2 anomalies. The first one, here on this coil, we have some black thing. That means this power supply suffers too much heat. Maybe it's just black glue. I don't know that. The other thing, where's that chip? Here. I don't know what this chip, probably, because here it's meant to have the network card. So this might be the network IC, maybe. We have 2 pins which are corroded. So let's try. The thing is, I don't know where the power button is connected or is coming from the keyboard. That's what we don't know. Yeah, the corrosion is not that much. Okay. So Which one is the power on button? Let's check these connectors together. We have this connector. Obviously, this is the connector for the screen. This connector is for the BIOS battery. Which connector do we know? This one is for the battery. This one is connecting some USB things and the audio jack. This one is for the keyboard. So I have three connectors which I don't know. This one and this one and this one. And the keyboard. So I want to check on. Let's pay attention to the connector for the keyboard and for these three connectors. We want to see where we can get 3.3 volts. Where we can get 3.3 volts on this one. Okay. On this one. 3.3. We have 3.3 here. 3.3. We have 3.3 on this connector. Here. Here we have nothing. Here. We have nothing. Here. On the keyboard we have 3.3. So out of these four connectors, this 3.3, okay, you know what, let's do a research here. A research that we are going to do, I want to see if I can get the schematic for this motherboard. Anything that I might get for this motherboard, because we want to be sure. I don't want to short the pin to ground, which I'm not sure whether that pin is going to ground or not. So I'll go on desktop. Go. We'll search this. This is the laptop that I was talking about. It's an Acer Aspire G, not this one. Yeah, this one, Acer Aspire G. I want to see how the laptop look like. I want to see how the laptop look like. Why am I doing this? Because this is going to, we are going to locate where the switch button either is on the keyboard or not. So we need a clear picture. Yeah, that's the laptop. If we check on the laptop, the switch button is on the keyboard. The last far end of the keyboard here, that is the switch button. So we found the switch button to be on the keyboard. So this 3.3, we are safe to short it to ground. We are safe to short pin number 2 to ground. We want to see what will happen to the current. Pin number 2. The motherboard. I've seen something. You have seen something on the variable power supply. Pay attention to the current there. The current is going to, now it's dead. Okay. 1 milliamp. Let's pay attention to the current. Pin number 2. We short it 600, 500, and it's going to 0. Oh, the problem, we don't have casing. We don't have casing, so we don't know what this motherboard. Do you have any light? Do you have anything? We don't have battery. But they said they said he tried to reprogram the BIOS, 2, 3 bin files. At the end, he pushed the original bin file. So that is the reason why I'm ignoring the the BIOS thing, yeah, to reprogram the BIOS chip. That is the last thing. We might confirm whether the bin file was installed properly or not, but this is not the case where we have to reprogram the BIOS chip. This is a motherboard fault. So what I will do before I look for the schematics of this motherboard, I want to check the resistance of every coil to ground. Here, ohms, here, how many ohms? 34 ohms. Here, how many ohms? 8 ohms. Here, 4 ohms. And here, 0 ohms. You remember that coil? We talked about this coil. I was suspicious about the color of the coil, and based on the thing that we have some black thing around this coil. And exactly here, we have 0 ohms. So 0 ohms doesn't look good. Huh? And on the next coil, we have 4.5 ohms. Okay. On other coils, 7 kilo ohms here on the RAM, 215. The 5 volts power supply, 6 mega ohms here, 42 mega ohms here, CPU 13 ohms here, 334 ohms. But why here we have 0 ohms? Yeah, we have 0. You know, this is the moment when we need schematics. So let me look for the schematics. If I can get it, we try to look and see what's going on here. Because here, this is the vehicle section. We can't check the MOSFETs on the board. Obviously, they are beeping from one side to another because of the internal resistance of the CPU. You see, this one is beeping here. This is not beeping. But this is beeping. The one which doesn't show the black thing, because here, this one is beeping, but this one is not beeping. But here, that is my suspect coil. So let me look for schematics or board view, and we'll continue the repair. 15 minutes later, what did I find? I found something. I found the schematics for this one, which is here. Yeah, that's the schematics. That is schematics. If you check this board number here, C5V01MB LAE89P, that is same board number. This board number, if you check it closely, that's the same board number that we have on the motherboard. So let's see where are the power supplies. Where are the power supplies? Where are the power supplies? Usually power supplies are on the last pages. Power supplies. LCD power circuit. No. What do you have here? LAN. Network IC. Wireless SATA. Audio IC. Where are the power supplies for this motherboard? ENE KB90. That's the ENE chip, this one. And the fact that the motherboard is trying to respond when you short 3.3 to grounds, I will say the E.T.C chip is trying to turn on the motherboard, but for some reasons it's not. For some reasons it's not. So I will not concentrate on the E.T.C chip. So let's move far away from the E.T.C chip. That's the input section. So here we have the DC in. We have this MOSFET. We have the current sensor. The power flow is coming from the charging port this direction. Going to a switching power supply where there is BQ chip. You see this BQ chip? This one, BQ735. With two MOSFETs here and the coil on the output, and the current sensor, which is giving feedback to pin 2 and 3. So it's coming back here for the feedback. Back here and for the feedback. Where's the AC detect pin? We checked here. The only BQ chip is not our issue, and the power from the battery is going this direction through this PQ305, this MOSFET. And our input MOSFET, let's refresh this. We refresh it. 7506 and 6366. These are N-channel MOSFET. The last number is an even number. The last number here and the last number here. What I want to check, what I'm interested with, here's the 3.3 and 5 volt regulator, which in our case is, do you think coming on and goes off, we have short on the VREC 5 or 5 volts LDO? We can check for 5 volts LDO, which is LDO 5 volts, pin number 13. I want to check this pin because we have a capacitor there. We have a ceramic capacitor on pin number 13 of this chip, RT6575. That's what I want to check. That's what I want to check. So I'll go under microscope. I'll go under microscope and check for where's this regulator. This is the BQ chip. This is for the RAM. We have 2 coils output capacitor. Because on the other side, yeah, that's the one. So I want to check for pin number. It's pin number what? I want to check on pin number 13. Let's check on pin number 13 of this chip. Pin number 13, pin number 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13. Pin number 13. I can see the ceramic cap, which is being stated from the schematic, but was this is the V in and the 5 volts. You see, this is pin number 13. We do have the 5 volts LDO exactly on pin number 13. So what I will check further if I go on the desktop will be okay. Let's see the vehicle section. This is the RAM power supply. Yeah. RT8207. This is for the RAM solution. This driver is for DDR4 RAM. That's the RAM driver. What I'm interested with is the CPU power supply. NCP 82206. This is the driver for the vehicle. That's the driver. So many pins. CPU. I think, yeah, VCC core. Let's see whether, let's try to locate this, where's that coil? Not coil, but let's try to locate PQ903. 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 Or PQ903. PQ903 is here. is here. So actually these MOSFETs, if you check this MOSFET and this MOSFET, we have here 4 pins, which is drain. We have the gate. We have a 3 pin source. And we have the gate. Okay, let's go back to our problem. Let's go back to our problem. Because what I want to check here, I want to check what kind of MOSFET is this. Yeah, I think now it's now clear. If we check on this MOSFET here, we have gate here. We have another gate here. So this is a dual MOSFET, right? This must be a dual MOSFET. So anyway, what we have to do in this case, on a coil with 0 ohms, let's lower the current. Current and voltage 0. I want to see with 0.8 volts. 0.8 volts is we'll be playing safe. I want to see what is going to consume the current. I want to see what is taking this current. Ground. This is ground. So I'll come with 0.8 volts exactly on this coil. Right. Check this dual MOSFET. Is this not our suspect? Plug in the power. See the liquid on top of the MOSFET? Okay. I can't feel too much heat and I don't want to raise the current because we might end up in big problem in case if the CPU is still right. So what I'll do is very simple. I'll try to take down this MOSFET and see the resistance of that coil again to ground. That's more easy to take down the MOSFET and we check the resistance of that power supply to ground. Do we still have 0 ohms or not? Okay. The MOSFET is out. Let's check what do we have on this MOSFET. Exactly what I told you. This is a dual MOSFET. We have this gate. So let's test let's check this MOSFET. Drain to drain. Yeah, the MOSFET is shorted. You can see. What about here? So one of these MOSFET is shorted. The other one, because inside this driver we have two MOSFET inside, and one is shorted, the other one is good. No? No? So ohms, what ohms do we have now on the same coil? 2 points. Like 3 ohms. Okay. So let me look for a dual MOSFET and we'll try to replace it. I found something, but what I want to do, I want to clean here. We add flux and obvious hot air. I found something. Where's my MOSFET? Where's my MOSFET? So here, where there's a mark, we have a mark here, which is pin number 1. So on our MOSFET, our mark, so this is supposed to be like this. Okay. This is a make sure job. We don't know if this is going to work or not. But that's what we have right now. The MOSFET is inserted in place. Checking the resistance with this MOSFET. I just checked this MOSFET. An N-channel dual MOSFET from another donor board for space. Now we have 1 ohm. 1.5 ohms. Okay. So yeah, this is not an easy repair. This is not an easy repair because we have to make sure. Now let's see how this motherboard is going to react. Let's see how this motherboard is going to react. We still have same standby current, which is 1 milliamp. Okay. So what I would do, I'll go on that pin. Where is my tweezer? My favorite tweezer, where are you? Okay, let me use this one, but this is not my favorite tweezer. I do have my tweezer that I love most. Shorting pin number 2 to ground, 600, and the CPU is getting warm. Huh? This motherboard is turning on, really? Let's check under thermal camera. We want to pay attention to the CPU. When I try to power on here, you can see the CPU heating up. That means now the motherboard is off. Now the motherboard is off. So what I would do, I'm shorting pin number 2 to ground on the keyboard connector. Check on the CPU. The laptop is on. Huh? Let me check the voltage. Very fast because we don't want no voltage. Here we have 1 volt. Here on the other coil we have voltage. On the other one we don't have. Maybe the other one is switching on when the motherboard is now consuming more power. That's not a big issue. But how can I test this? How can I test this? Let me power on this TV and try to connect the HDMI, because we do have the HDMI here. So I'll switch to the TV. Yeah, that's the TV. That's the TV where we need to pay attention to HDMI. Maybe we're not going to see any picture there. Let's short pin number 2 to ground. Yeah, the motherboard is on. I can see based on the current picture. Where are you? It's taking 500. The current is fluctuating, which is a good sign. 500, 600. Don't tell me that we did not manage to fix this. Yes, because maybe they reset Acer. You see the Acer? Check there. No bootable device. We fix it. We fix it. Huh? We managed to fix it. Huh? Yeah, the CPU is getting very hot. We did it. Check there. No bootable device. Let me disconnect. We did it. Huh? Like really? Like really? No. Seems like it's a dream, but we have done it. So here, that was a big process because I tried to do this step by step for the purpose of learning. Maybe if this was off camera, I was going to do it in maybe 15, 20 minutes. I see this coil. I check, I saw the dual MOSFET and the MOSFET that we replace. That's the MOSFET. This is a dual MOSFET with 2 gates. Dual N-channel MOSFET. So I replaced with another dual N-channel MOSFET from an HP motherboard. The motherboard which is not even tally with this one. Oh, so the job is done. The job is done, and I'm very happy about this repair. I'm very happy. You know what? I'm not even believing that we fix it. Let's test again. Let's test again. Repetition. Testing once is not enough. Let's test again. I'll adjust my webcam and I'll short pin number 2. Yeah, the motherboard is on. We don't have CMOS battery, we don't have anything. So this is just a motherboard. Let's wait for the Acer log. Maybe this time we won't see it. The motherboard is coming on, and Acer, no bootable device. Let's disconnect here. So I would say to my friends, your faith pays. Yeah. The power of faith. You trust someone that he doesn't know. I don't even know the guy. But based on the fact that he trusts us, we try by all means to do step by step. This is a nice motherboard. So if we have this motherboard, it's coming on and goes off, we reprogram the BIOS not working. The 5 volts LDO is not shorted to ground. Mostly the USB there will be fine. Check other things. Check the vehicle section for the CPU. So I'm happy that technicians, they know. You see, if you see a technician who know where to stop, that will be a good person. If you know your limits, that will be a good person. What I like, he phoned me, he told me that we reprogram the BIOS. Of course, they do reprogramming the BIOS. It did not work and they put back the original bin file. He explained everything about that. And when I was speaking with the guy, you know, when you are speaking with someone who doesn't know electronics, and you are speaking with someone with knowledge of what he is talking about. So we managed to fix it. But they were saying this came to their workshop from their loyal customer who has a studio in the capital city. So this is an i7 motherboard. So maybe they are working with big softwares. Obvious, when the laptop is dead, you want it to be fixed. You can't, maybe you don't have the budget to buy another one. But I'm happy we managed to fix this. We managed to fix this. You know, I feel happy when I fix such motherboards. I like fixing old motherboards. Of course, this is not too old because we have some USB-C ports. Yeah. We still have a working GPU, which was my prayer. I know that we might be able to fix the motherboard and we fail to get the picture. But if you get the picture, it means the job was done. Was a well done job. That was a well done job. That was a well done job. I would say to my friend, Thank you for trusting us, and don't hesitate to send another jobs. If you find another jobs from the capital city, yeah, don't hesitate to send them so that we can check what we can afford to check. Of course, we are not fixing everything, but we can check on another angle, which is different from the way how you were checking your motherboard. So, don't forget to turn on the notification bell for future updates. And if you have anything that you wish to add or to subtract, don't hesitate to leave a comment. And yeah, will be something else on the next video. Bye bye.